You know, I think I want to try my hand at another YouTube tutorial series. I just don't really want to restate all the things that I already said in my KSP tutorial. If only there was a sequel space and rocket building game that I could try out. Welcome to Juno New Origins, a space and rocket simulator similar to Kerbal Space Program. Like KSP, in this game you'll manage your space program, building rockets, airplanes, and other vehicles to explore a rather large solar system. In this first tutorial, I will show you how to build your first set of rockets and show you how to get from launching small sounding rockets to flying orbital payloads for your customers. One of the nice things about Juno is the inclusion of basic tutorials, and even a tutorial as you play the campaign that can help you get yourself going. While these are going to be helpful, I am going to actually skip all of that, and I'm going to assume that you've either played the tutorial or understand the basics of building and flying in Juno. The tutorial is mainly focused on the campaign, meant to show you how to optimize your vehicles for completing contracts and which tech nodes to unlock for which route you want to take in order to unlock the launch centers. And this first video will be covering early tech trees for rockets and how you will build your first orbital rocket and unlock the Ollie launch complex. Juno is a game that is built on your creativity, so I don't recommend you recreate any of the vehicles that you see me build in this video. While they can be helpful and they will be able to accomplish the missions, I recommend you go and build your own designs and get creative, developing your own techniques and learning how to build and design your rockets. Before we jump into the campaign, let's talk a little bit about how you progress in Juno New Origins. There are three major launch sites that you can launch from: the DSC or Drew Space Center, the Ollie Military Base, and the Juno Village. Each site has a runway and launch pad for you to launch at, and the DSC has a boat launch area for if you want to build watercraft. Instead of upgrading a single launch site, all of these launch sites are already built and ready to be used. But you have to show the owners of these launch sites that you are able to help them accomplish contracts and work for them in order to have access to them. Starting in the Juno Village with small model rockets to launching massive deep space rockets from the DSC Super Heavy launch pad. Additionally, the way you unlock the tech tree is very different from KSP. In Juno, you complete contracts and milestones as an aerospace contractor. By completing each of these increasingly difficult milestones, you'll unlock more and more tech points, which will allow you to unlock the tech you need to build better rockets, aircraft, cars, and boats. But in order for you to complete these milestones, you need to have money, and to get money, you need to accept contracts. Your first few contracts will be offered by this cowboy. He kind of looks like Sam Elliott, unless you have the Anime Waifus mod installed. But I'm not a degenerate, so I don't know what he looks like with that mod. Sam here is the mayor, or sheriff, or local dictator of the Juno Village. He wants to bring an aerospace company to operate out of the village. Unfortunately, he built a tiny launch pad, and the runway to the village is a ramp in the middle of a massive mountain range. So when you move in, you'll want to get literally any other launch site for any of your vehicles. Just being honest with you, Sam, I appreciate you giving us a starting location, but it sucks, and you should go back to the drawing board with these facilities. Anyway, no matter which path you take, rocket or airplane, Sam here will help you get off the ground, quite literally, because the runways are... With the rocket path, he wants you to build a rocket that can go from the launch pad up to 25 kilometers above sea level. He'll also give you contracts to do increasingly further downrange milestones and have you do a fireworks show sort of contract, but all of these can be accomplished with the same rocket, aside from the fireworks show rocket, which I often skip and don't do those contracts. But you can if you are short on money. To build this rocket, all you need to do is have an aerodynamic nose cone, a body tube or fuel tank, one of the solid rocket nozzles, and a set of fins to help guide the rocket. With all of this, you can open the options for the flight computer and just load in some batteries, and I would recommend adding the max amount of gyroscope just to make it easier to keep the rocket pointed in the right direction, although it is optional. Make sure you have a little more than 1.8 kilometers per second of delta V in your design info window, and a thrust to weight ratio of more than 1.5. This should be more than enough to get you the acceleration you need to get, and enough fuel to get the push you need to get to that 25 kilometer ASL. Once you complete that first contract, you'll then unlock a number of contracts, such as the flight termination contract, which again is optional for me, and then the going sideways contracts. Because this rocket is so cheap, simply accomplish as many of these contracts as you can in order to both save money and time developing a new vehicle. And when you find a contract that you can't quite accomplish, start by making slight tweaks to the current rocket that you have, such as adding more fuel or making it lighter, up until the point where you simply cannot do it, and then it's time to build your second vehicle. For your second vehicle, I would recommend just adding a second stage to the rocket that you've already built. Using the tech points I unlocked by completing some of these first flights, I would unlock the parts that would get you the interstage node, as well as unlocking the tech node to allow for more than one stage. This new rocket should have a little more than 3 kilometers of delta V. Again, ensure that your thrust to weight ratio is more than 1.5, but with this new rocket you can now accomplish all the remaining contracts up until it's time to launch a rocket into orbit. You'll need to change how you fly this rocket depending on how powerful it is or any other parameters, but continue to fly this rocket to help build up more money, and then you'll be able to eventually unlock all the parts you need to build your first orbital rocket. If you've played Kerbal Space Program before, you know that to get into orbit you need to fly above the atmosphere and fly fast enough that the planet's curvature drops away from you as fast as you fall towards it. Of course, to accomplish this, you need enough fuel to get into space, around 3 kilometers per second in Juno, and then enough fuel to raise your periapsis so that it weighs above the atmosphere of the planet you want to orbit. While getting into orbit itself is a rather simple task, it would be very, very difficult to do it with the parts that we currently have unlocked. Instead, what I would recommend you do is unlock the liquid fuel engine in the game, the GNOME engine, a small pressure-fed engine which can restart and use kerosene and liquid oxygen. To build this rocket, I like to build a 2-stage rocket that uses a single engine for the upper stage. This upper stage will have a little more than 1 kilometer per second of delta V. In order to make the engine for this stage more efficient, I like to change the shape of my engine and increase the length of the nozzle to help improve my ISP, and through that my delta V on this stage. This does mean that this cannot be used safely in the atmosphere though, as the engine can take damage from overexpansion. So make those edits with the idea of where you're going to be using the engine in mind. Moving to my first stage, I like to copy the engine I used on top and lower the nozzle extension to make it more optimized for sea level and in atmosphere flight, just like how real rockets are designed. I like to copy the same engine for the upper stage to my lower stage because in real rockets, rockets like Starship or Falcon 9, depending on the rocket that you build, it is easier to use the same engine, just a vacuum optimized or sea level optimized version on both stages to simplify the development. This isn't really needed for Juno, but it is something that I enjoy doing for realism. Additionally, I enjoy adding a automated launch program using the built-in programming language Visi. It's very similar to Scratch, and for this I have this basic launch program that allows me to edit my rocket's final orbit here in the Visi programming language, and the rocket will be as close as it can get to the orbit that I want it to be in when the engine stops firing. To break down how I made this program, I created custom instructions to break my code down into easier to read sections. The Custom Instructions tab is down near the bottom of the side menu, and selecting Create New Instruction allows you to create custom instructions and add them wherever you need them. To help give you some inspiration for how to make your own programs, I'll break down my code so that way you can see how I accomplished it. First off, I added a countdown function. The countdown function allows me to set a specific amount of time before the rocket automatically launches, allowing me to decide if this rocket is able to accomplish the mission that I have set out for it, and if I need to, I can recover it rather than undo all the way back to the editor screen, allowing me to get my full money back. To get my vehicle to fully automatically perform a countdown, I create a variable in the Create Custom Variable tab. This variable, called Countdown, is automatically set to whatever I want my starting number for the countdown to be. Then, while the variable is still greater than 0, it will perform the countdown instruction. In the countdown instruction, it simply sets the variable countdown to 1 less than it already was, waits 1 second, then records what the countdown variable is in the flight log. I did that for debugging purposes. When the countdown is equal to 0, the code will then perform the liftoff instruction. In liftoff, the vehicle will set its heading to the required heading, in this situation 90 degrees or directly east. It sets the craft pitch to straight up or 90 degrees from the horizon, and sets the throttle to 100%. Shown in the code is a number between 1 and 0. It then activates the stage, shows that it's activated the stage by putting in the words liftoff in the flight log for debugging purposes, and then waits 5 seconds to allow the rocket to pick up speed and altitude before moving on to the ascent instruction. In the ascent instruction, while the apoapsis of our orbit is below our desired apoapsis, it will constantly update the pitch to whatever the result of this equation is. This equation is an equation that I found that would automatically set our pitch to the required amounts based on its altitude above sea level. While it sets the pitch, it also monitors its thrust to weight ratio, ensuring that it stays around 3. This is optional, and I do this so that the vehicle doesn't accelerate too quickly and risk burning up in the atmosphere, and for realism to limit the amount of G's that the payload would experience during launch. While the vehicle is in ascent program, it also performs the auto stage instruction. Auto stage will check if the fuel of the current stage is less than or equal to 0. Then, when that is the case, it will automatically activate the next stage. This will ensure that the program continues to check if the fuel in the stage is less than 0, but will still perform the other instructions in the ascent program. When the apoapsis gets above the required level, it will automatically run the orbital insertion instruction. Orbital insertion shuts the engine off, locks the heading on prograde, and then prepares us for the burn to raise our periapsis. It'll then wait until our time to apoapsis is lower than a certain amount of time. Then, while the periapsis is below what we want to set our periapsis to, it'll set the throttle to full. And once the periapsis is above our required levels, it will set the throttle to 0 to shut the engine off. Once that is complete, the rocket will be in orbit relatively close to our required orbit. Once you have launched your first orbital rocket, you'll be introduced to a new contract provider, Professor Pricklespack, who I like to call Donald. Donald is a scientist who I assume lives in or near the Juno village and wants you to launch vehicles into specific orbits. I assume to show him that your rocket can launch into these specific orbits for his satellites. He will then have you launch CubeSats that he provides and eventually larger satellites that will require larger rockets to get into orbit. But don't worry too much about those yet. Your first orbital rocket should be able to get these early contracts very easily. Continue to accomplish these early orbital contracts and the CubeSat contracts until you finally have the new customer, Chuck Schaefer. Chuck will be the savior that will get you out of the Juno village and its terrible launch pad. He runs the Ollie military base, and if you're able to launch a vehicle into orbit in less than 5 minutes, he'll let you use the Ollie pad at his military base. The launch pad is closer to the equator and has much larger size and weight limits to what your rockets can be, and will be our main launch pad for the foreseeable future. To accomplish this contract, simply have your vehicle go into a low orbit around Drew, about as low as you can reasonably go into orbit, and you'll easily be able to beat that time limit. With that, I'm going to leave this video here. In our next episode, I'm going to talk about aircraft and cars and how to build them so you can unlock the Ollie base for launching your airplanes and doing other really cool things. If you enjoyed this video, please let me know down in the comments, as the engagement will help tell YouTube that this video is one that should be spread around a little bit more. If you want to see more, go and subscribe. And thanks as always for watching, and as always, keep looking up.